Hi students. So in this lecture we're going to talk about the preparation of K2MnO4 and KMnO4. Okay. So K2MnO4 is called as potassium manganate and KMnO4 is called as potassium permanganate. In simple word, if it breaks, it will break into MnO4 2 minus. So MnO4 2 minus is called as potassium. Sorry, MnO4 2 minus is called as manganate. And what if potassium permanganate breaks? Then it will break into K plus and MnO4 minus. So MnO4 minus is your permanganate, where manganese is at plus 7 oxidation state. Whereas in manganate, manganese is at plus 6 oxidation state. Hope it's clear, guys. So we're gonna talk about the preparation. Okay. So first of all, we'll start with the manganate only. We take MnO2. MnO2 is a ore of manganese, which is called as pyrolusite, and its color is brown. It is treated with potassium hydroxide base along with oxygen, and then we get MnO4 2 minus manganate ion, which is green in color. Okay. Now, in place of oxygen, sometimes we take KClO3 or sometimes we take KNO3. Okay, either we take oxygen or we take KClO3 potassium chlorate or we take potassium nitrate. So what are their roles? What if I take potassium chlorate or potassium nitrate? What's the purpose? Actually, when you break, when you heat potassium chlorate or when you heat potassium nitrate, they all will decompose to give oxygen. Means, if you suppose if you heat potassium nitrate, so potassium nitrate on heating decomposes into potassium nitrite and oxygen. Whereas if you try to decompose potassium chlorate, it will decompose into potassium chloride and oxygen. Now one interesting thing here is that potassium chlorate does not decompose easily. Okay, when you heat it, it does not decompose easily. And for that purpose, we use MnO2 manganese oxide as a catalyst. Okay, the MnO2, which is acting as a catalyst here, and that helps to break down the potassium chloride and which gives you oxygen further. In other words, you can say that the reactant itself, in this case, the reactant itself behaving as a catalyst, right? Or you can also call it as self catalyst or auto catalyst because the reactant itself behaving as a catalyst. So such type of catalysts are called as auto catalyst. Hope it's clear. So that's their objective of potassium nitrate or potassium chloride to generate oxygen. This oxygen is used in the conversion of MnO2 or oxidation of MnO2 into manganate ion. Hope it's clear. And if you see, I have written the key points also. Note the purpose of O2, potassium chlorate and potassium nitrate, is to generate O2, which helps in the oxidation of MnO2 into MnO4 2 minus मैग्नेट आयन में बनाने में हेल्प करता है. ठीक है. So we have covered this segment, correct? Now we have covered also this segment. If you want to see the structure, this is a structure of MnO4 2 minus magnet ion. This is green. So manganese, single bond oxygen, negative charge, double bond, again double bond, and again silver single bond oxygen and negative charge. If you look at here, MnO4 minus permanganate ion, which is actually purple in or light dark pink or purple, you can say purple or pink, you can say Mn single bond oxygen minus double bond oxygen, double bond oxygen, double bond oxygen. So this is the structure of MnO4 2 minus and MnO4 minus. Okay, moving ahead. Now I want to tell you very important thing about MnO4 2 minus. Okay, manganate ion has a different behavior. It has a property, it has a specific property. What is it? So MnO4 2 minus has a characteristic. It disproportionates into MnO4 and minus and MnO2. Means the manganate ion disproportionates into permanganate and MnO2 in presence of acidic, neutral or slightly alkaline medium. That's the problem. MnO4 2 minus means manganate ion in presence of acidic medium or neutral medium or slightly alkaline medium will disproportionate into MnO2 and MnO4 minus. Correct? Now you think that you want to prepare manganate ion, right? If you want to prepare manganate ion, if you want to prepare the manganate ion, you have to provide a strong basic medium. You have to provide a strong alkaline medium so that the disproportionation should not take place. To avoid disproportionation and to make sure that manganate ion is stable, you need to provide a strong basic or alkaline medium. Otherwise, it will disproportionate. Then, what is the use of preparing MnO4 2 minus? The manganate ion will be disproportionate and it will not be stable. I mean, so if you want to prepare it, that means you want to store it, and if you want to store it, you have to provide a strong basic medium. Is it clear, guys? So now we have written like this one. So this was the point I have also written. So if you want to prepare MnO4 2 minus, you need to supply strong alkaline medium to avoid disproportionation. Hence, this is the reaction, the final reaction. We are on the final step, right? Means pyrolusite reacting with KOH, any oxidizing agent, we get MnO4 2 minus, manganate ion, green in color, and then we have provided a strong basic medium so that it remains stable. And I have written also. Now, what if you treat with NaOH and what if you treat with KOH? What will happen? If you treat with further KOH, you will get K2MnO4, and if you treat with NaOH, you will get Na2MnO4 dot 10H2O. Wow, this is a very interesting thing. In this case, you got Na2MnO4 dot 10H2O, whereas in place of KOH, you got K2MnO4 potassium manganate. Why they are two different? Although sodium and potassium belong to the same group, but why the water has come into the picture? This is water of crystallization or water of the hydrated molecules. Why so? This is like the answer I have given in the last lecture. I said that sodium is hygroscopic or deliquescent. We can use two words. We can either say deliquescent or we can also say hygroscopic. Means they have a tendency of absorbing moisture. And you remember that's the reason we don't use Na2Cr2O7 in volumetric analysis, because they will absorb water molecule, right? And the readings will not be accurate. The end point will not be accurate. So this is something I wanted to tell you. I want to tell you that I wanted to explain you the hygroscopic or deliquescent nature of NaOH, I mean sodium only. That's why I gave you two reaction. You can see the contrast here. In place of KOH, I'm getting a very simple compound, but in place of NaOH, I'm getting this one. Hope you have understood this. Now I have also written further isomorphous. Isomorphous means you will see that two compounds will look similar in crystalline structure, but they have different physical and chemical properties. Compounds having having similar crystalline structure, compounds having similar crystalline structure but different physical and chemical properties are called as isomorphous. तो होता क्या है isomorphous में, the formula will look somewhat similar, pattern will look similar, just like here Na2 manganese. Okay, here we have sulfur and O4. So Na2MnO4 dot NH2O, and if you look at this formula Na2SO4 dot NH2O, can you compare that the formula pattern looks similar? The pattern looks similar. That's what it is. If the pattern looks similar, they will have same crystalline structure, but they will have different physical and chemical properties, and they are called as isomorphous. Similarly, K2MnO4 is isomorphous with K2SO4. I hope, guys, the things are clear till this point, right? Okay. Now that means I have discussed till this part. This part is covered. Now, moving ahead, there is a lab method to prepare K2MnO4. You take potassium permanganate, treat with KOH, and boil, means heat it. Boil means around like 70, 80, or 100 degrees Celsius approximately, and then you will get this near to 100 degrees Celsius. You have got potassium manganate, water, and oxygen. So this is all about preparation of K2MnO4. Now we will move on to the preparation of KMnO4, potassium permanganate. As we know that manganate ion has a disproportionation tendency. If you supply acidic medium, neutral medium, or slightly alkaline, they disproportionate. So we will use the same application, we will use the same characteristic, and we will supply the acidic medium in manganate ion. I have supplied the acidic medium, and when I supplied the acidic medium in the manganate ion, I got permanganate and MnO2. Disproportionation has taken place even here. One more thing, H2O plus CO2 in, like, this is actually another way of writing H2CO3. Both will combine to form H2CO3 and carbonic acid. This is what we know. So manganate on in presence of carbonic acid will give you permanganate and MnO2. Disproportionation. But now the actual problem arises here. When this reaction taking place, my goal is to prepare KMnO4, permanganate, potassium permanganate. But some part of manganese is getting wasted in presence of in the form of MnO2, manganese oxide. What I'm trying to say, when I'm trying to prepare KMnO4 by this method, then some part of manganese is getting converted into MnO2. Correct. So that is a waste of manganese. As a industrial, let's suppose if you have a factory, let's say you own a factory, what do you want? You want your all raw materials should be used properly, right? Cost of production should be less, and you should get maximum output, right? This is our goal, this is what we want. But what is happening here, some part of manganese is getting converted to MnO2, which is kind of waste for us. I want all manganese to be converted into permanganate. Understood? And for that purpose only, we prefer other method over this method. We prefer other method over this. We discard this method. So what's the best method? You have manganate, treat with ozone, you will get permanganate. Or you have manganate, K2MnO4, potassium manganate, you treat with chlorine water. Again, you will get permanganate. Done. It's easy. You have to memorize these reactions for sure. There is no other way around. I'm telling you guys, no other way around. If you want to score in D block elements chapter, you have to memorize these reactions. There is no other way. So I have tried to summarize the whole thing. Whichever reactions are important, whatever things are important, I have added up. So kindly memorize and try to solve the questions. Moving ahead, potassium permanganate is a powerful oxidizing agent that we know. Manganese here is at +7 oxidation state. So there is again one characteristic about manganese. So in neutral and faintly means slightly alkaline, slightly neutral and faintly alkaline medium, the MnO4 minus means permanganate ion. This MnO4 minus changes into MnO2. In acidic medium, it changes into Mn2 plus. Mn2 plus. तो आपको ये भी याद करना है. In acidic medium, MnO4 minus changes into Mn2 plus. In neutral or faintly alkaline medium, it is changed into MnO2. In strongly alkaline medium, it will change into MnO4 2 minus. Manganate ion में change हो जाएगा. So I minus changing into IO3 minus, S2O3 will change into sulfate ion, thiosulfate will change into sulfate, and then manganese 2 plus from any salt that will directly change into MnO2. In acidic medium, I minus will change into I2, thiosulfate will change into sulfur and sulfate. Okay, they have undergone oxidation. Hope this is clear, guys. Moving ahead, so I have written this, the thing which I was explaining right now, na? That a magnet in acidic medium, magnet in basic medium, or the magnet in neutral medium, what happens? So look at here, permanganate in acidic medium, Mn2 plus, permanganate in neutral medium, MnO2, and permanganate in strong, like alkaline medium, basic medium, it changes into manganate ion. Hope it is clear, guys. Moving to the next question, that is inside question. During titration over KMnO4, we never take HCl as an acidic medium. Why? Because if you take HCl, HCl may, Cl is at minus 1 oxidation state, and Cl minus 1 behaves as a reducing agent, and we all know MnO4 2 minus behaves as an oxidizing agent. So there will be a redox reaction between MnO4 2 minus. My mistake. I wanted to write MnO4 minus per magnet. Okay, MnO4 minus. So that is an oxidizing agent, and Cl minus is a reducing agent. So like the redox reaction will take place, and then Cl minus will change into Cl2. The redox reaction will take place, and then Cl minus will change into Cl2. And when it will form Cl2, though Cl2 will not help in making the solution acidic. The solution will no longer remain acidic. The solution will no longer remain acidic, and but for titration we prefer acidic medium. So in short, HCl is not helping in making the solution acidic because of KMnO4, because it undergoes oxidation. That's why we don't prefer. And for that purpose, we prefer sulfuric acid. Hope this is clear, guys. Now, one important reaction, oxalic acid versus KMnO4. This is again very important topic. MnO4 per magnet, which is purple, and oxalic acid का ion होगा oxalate ion. Oxalate ion in acidic medium we get Mn2 plus and CO2. A very good titration we do in generally lab and all. So if you remember, if you know, initially we required to heat the reaction for 60 to 70 degrees Celsius for 3-4 minutes. Initially heating is required, but after 3-4 minutes heating is not needed. After 3-4-5 minutes heating is not needed. Why? Because when the reaction starts, when you start heating the reaction, then the reaction proceeds, and then Mn2 plus forms, some amount of Mn2 plus forms, right? सपोज आपने ये भी 1 मोल लिया, ये भी 1 मोल, तो ठीक है, सम 0.1 मोल हैज बीन कंज्यूम्ड एंड ऑल, सो यू विल गेट 0.1 मोल of something Mn2 plus, right? And that Mn2 plus will behave as a catalyst, and that lowers down the activation energy, and that's the reason heating is not further needed. The moment Mn2 plus is formed, heating is not needed. The moment it is formed, heating is not required. That's why we say heating is not needed after 4-5 minutes, because the Mn2 plus formed here itself behaving as a catalyst. And again, such type of catalyst are called as autocatalyst, because the reactant or the product itself behaving as a catalyst, right? And one interesting thing, the MnO4 minus itself behaving as an indicator, because if see, initially its color is purple, but the moment it changes into Mn2 plus, it becomes colorless. So after some time, all the purple color disappears. That shows that MnO4 minus has been completely consumed. That has been completely consumed. So that itself behaves as an indicator. Such indicators are called as self indicator. तो आप ये स्टेटमेंट देख सकते हो, ड्यूरिंग टाइट्रेशन हीटिंग इज नीडेड फॉर 4-5 minutes. Further heating is not required because manganese formed behaves as an autocatalyst. In this process, KMnO4 acts as a self indicator. That I have explained. The last topic of KMnO4 part. KMnO4 in presence of KOH gives K2MnO4, manganate, water and oxygen, and I have given this reaction earlier. See here, this reaction. Okay, that is a heating effect. Another, if you heat potassium permanganate at 750 Kelvin, you will get potassium manganate, manganese oxide and oxygen. And if you further heat, red heat means red hot means superheated. If it is superheated, it will give you K2MnO3 plus oxygen. So you need to by heart all these reactions. Okay guys, so this is the, completion of compounds. In the next lecture, I'm going to discuss about chromyl chloride test and some important questions. And इस lecture के बाद further we will discuss like questions. I have a worksheet. I want to show you the worksheet. I have some questions. So I will discuss all set of questions. We have around 50 questions, 50. So we will discuss 50 questions, and these questions are SRG level, like top level questions, special rank group. I mean, in D block, you cannot have very tough question. In the end, it's memory based questions, means like you know the reaction, you memorize the reaction, you can easily solve, right? But I have tried to like collect questions from all possible resources, and these questions are really good. So we will solve these questions further. Okay, that way I will cover up in the next session. Moving ahead. So yeah, so this is all about, guys. So keep watching, keep learning the things, and keep practicing also. So thank you for very much for this lecture, guys. Thank you.